instead of the actual instructions, it's just do this mesh current. Do it.
Use mesh current analysis to find the currents through each resistor and the splice and the voltage across each resistor and each supply. So this is homework 9. Problem 4. So we have 20 volts here. Incidentally, this is a generic DC power supply with the circuit. If it's got the lines, it's a battery. This is technically the symbol for our sources over there. As you start to see some of those, feel free to ask. There are technical differences in all of them, and it's worth knowing at some point. I don't overly emphasize it in here, but so 4 I do mesh current, 5 I do nodal. See? That would make you prove to yourself it works. All right. That look great? So I would like to solve this. We might as well go down and put our mesh currents in. If it's okay with you, I'll just kind of draw them the standard way. This is I1.
Yeah.
This is I2. I can flip I2 if you want me to. It doesn't really matter which way I pick. And I'm going to draw I3 to go in. So it's the 4 amps. Oh, wait, I actually know what I3 is already, right?
Yeah, it's 4 volt or 4 amps, isn't it?
Yeah. So I'm going to work around loop 1 on the left. So I'll start here. I go up 20 volts. I will drop 5 ohms times I1. And then across here, I will drop 10 ohms times I1 in that direction. I2 is going to be the opposite direction, so minus I2. So, and again, I put the units down on these. If for me just solving it, I would skip the units here. And I would have just written down 20 minus 5I1 minus 10 I1 minus I2 equals 0. If you're comfortable doing this, go for it. The big thing is just remember, you gotta make sure everything's either in ohms or kiloohms.
Okay, so I kind of understood it a little differently.
Yeah.
So I'm curious if it worked. So could you just do 20, or basically minus 15 I1, because it's 5 plus 10 I1, and then minus 10 I2.
So it end up being 20 minus 5 minus 10 is minus 15 I1. Minus
Wait,
10 times
like
minus
that.
2 is plus 10 I2.
Oh, so I just kind of skipped that step.
And if you get here and you're doing it okay, that's fine.
Okay.
I just don't want to skip the steps now. I want to set it up.
Yeah. That's kind of how I imagined it with the circles, like with the loops.
Okay. I won't go on to the next loop until you let me know you're okay, John, because I know you're writing it down. Don't want to run off of that.
I'm finished writing it.
You said that right as I grabbed my super hot, ooh, it's hot still. Hot coffee. That's good though. All right, loop 2. I'll start at the bottom in the direction of I2. So I will have minus 10 I2 minus I1 going that direction. So It looks just like this one, but I2 and I1 are the other way around because I'm going the opposite direction. I'm following I2 around. Minus 10 I2 over here, minus 20 I2 plus I3 because they're going in the same direction. So everywhere where I'm dropping voltage due to resistors and negatives, so I'm going to put all negatives out front here because they're all just resistors. If I look at I1, minus 10 times minus I1 will become 10 I1. Minus 10 I2, minus 10 I2, minus 20 I2 is minus 40 I2. Finally, minus 20 times I3. I don't really need to do a loop here, do I? I know it's 4. So I can write these down now. I can write my equations down as 20 minus 15I1 plus 10I2 equals 0. That's one equation. The other equation I'll write down is going to be 10I1 minus 40I2 minus 20 times 5 amps, 4 amps, sorry. So in the end, I end up with minus 100 plus 10I1 minus 40I2 equals 0. So I've got 2 equations. 2 equations, 2 unknowns. So yeah, this is one where my Kirchhoff's laws, I would end up with like 5 equations.
20 times 4 is 8.
Oh,
Wait,
you're right.
no.
Oh, no.
It's that, yeah.
Just checking that you're awake. That's the problem doing the board. Even simple ones like this, you're like, I screwed it up. Thank you. We'll leave this one on. We'll do the next one. Now I'm going to take this top equation, and if I take this equation and I multiply by 4, wow, that's not going to work out well, is it? 80. Let's see what happens. 4 times 15 is 60. 4 times that is 40I2. I add those equations, I get 0 minus 50I1 plus 0 equals 0. I suggest that the current from I1 is 0. Did I make a mistake somewhere? I already made one, so maybe I made another.
Maybe it's a faulty supply.
What would be a faulty supply? Just because this current is moving enough out that we end up with 20 volts here, which means that this never ends up with any voltage across. What's that? Did you solve? Did you do this one?
I turned it in already.
All right. Let's go ahead and try it. See where we go. It looks wrong, doesn't it? Let's find out.
Yeah.
All right, if that's 0, I'm just gonna go back up to this equation. 20 minus 15 times 0 plus 10I2, 0. So I2 equals minus 20 over 10, which is minus 2 amps. So what that will mean, if that's correct, all right, I'm going to write this part in green just so it's different, is that I have 4 amps that goes here. I2 is minus 2, which means actually 2 amps goes there and 2 amps goes there, right?
Yeah. So that makes sense.
Which means I end up with 40 volts right here. I get 20 volts right here. I2, which if this is 0, means my 2 amps goes down here, which is 20 volts. That means this is 0 volts here. So my supply is providing 40 volts, 4 amps. I end up with 40 volts across here, splits, I get 20 volts and 20 volts. So it splits in 2 amps here and 2 amps right here. And because of this voltage, this just isn't pushing anything out. I don't know if that's anything like you got, or maybe you got it, didn't believe it, because, you know, like I put the question mark here and went, is that right?
I got something very different.
Okay. Do you have questions about my process or the details?
Just look at your results.
I see a negative 1.33 amps for I1
Oh, that one.
from my original attempt.
Well, that one you did it right.
Current supplies are weird.
They're also new to, they're one of the things that's new to us.
I'm gonna look on the lab now, because I think I got this down.
Yeah, go for it. I believe it's mostly build things with 2 supplies and then remove one.
Yeah.
You do your calculations and or simulation again, and then build it and try and see if it actually works.
I have to get out another one of these big bricks. I'm already using 2 of them. But
Shouldn't, do you need one for this?
well, I'm trying to think, because I need to have 2 power supplies.
You could also use the terminal strip if that worked. If you need, somewhere over here on the blue,
Okay.
in the blue bottom of the one, the blue cabinets are more breadboards.
Can I put one of those alligator clips connected to the power supply, and then put it in here? Or will that be bad for it?
It's perfectly fine. Just make sure the trainer's power supply isn't connected to anything. And don't turn it on. Just use the breadboard part.
So I can't turn that on and then use one of the other power supplies.
Guess you can keep
No.
you can connect the grounds together.
Okay, now I'm confusing myself. I'll just try
If you need another breadboard though, if you go in those blue cabinets, the bottom one of the blue cabinets has some more breadboards. You can just grab a small one and use it, if that'll help.
Okay, I'm just gonna do that. But the left or the right one?
I don't know. I would have to go look. You can use one of the big ones, or you can use one of the tiny little ones down there. I don't care. Just put it back when you're done.
Yep.
Good? So you want me to move on and do it now with Nodal? So I can go about this various ways. I can look at, I'll actually, I'll make it like all the voltages are going away from there. So V1 minus 20 volts over 5 ohms, if we assume the current's going towards the source, probably isn't. Plus V1 minus 0, come down, this is going to be my ground, over 10 ohms, plus V1 minus V2 over 10 ohms, all these equals 0. Right, that's source 1. Hey, this one shouldn't be too bad. I can multiply through by 10. So I end up with 2V1 minus 40 volts plus V1 minus 0 plus V1 minus V2 equals 0. And with 4V1 minus V2 minus 40. So I write my equation down. Is that okay? Just went through and just took my equation. It has fractions, denominator, so I just looked at those and went, oh, if I just multiply it by 10, I get rid of all my denominators. So I'll multiply it by 10. 10 over 5 is 2, so I get 2V1, 40. 10 over 10 is canceled, so I just write that down. Is that good? I even did put here, times 10. I drop my ohms and my volts and all, so I just have an equation. Now for V2. I can write V2 much the same way with everything going away. So V2, V2 minus V1 over 10 ohms plus V2 minus 0 over 20 ohms going to ground. And you know what? Because I actually just have that current. That's just all equal to 4 amps. All right, this is just a current equation, really. All right, I just do the voltage across two ends of the resistor over the resistance would be a current. I'm going to multiply by 20 to get my denominator out. So 20 over 10 is 2 times each of these. So that's 2V2 minus 2V1. 20 over 20 cancels. Plus V2 minus 0 equals 20 times 4 is 80. So I'm all done. I can summarize this as minus 2 V1 plus 3 V2 equals 80. Two equations, two unknowns. Oh, you moved. I don't want to go further unless you're good with my two equations where I got them. Actually, I'm just going to check my algebra real quick. Okay.
have any single pole, double throw switches?
I will when we get done with the inverter second.
Yep.
Actually, you said that. I have one sitting right here.
Oh, nice.
This is for the capacitor model.
Yes, and the 100 UF capacitors are over there in the cabinet. Oh, perfect. Thank you.
Okay. I checked. I got the same answers as last time, so I'm feeling good about it. I'm guessing that the biggest issue was how do I deal with this 4 amp supply, but I don't know that. And yes, you guys were talking, there are algebra solvers out there. A lot of them expect you to use X and Y instead of like I1 and I2 or V1 and V2. You just replace those with X and Y. And I don't care if you use them to double check yourself, but on the test chip, you be able to do it by yourself. Just like I don't mind at all you dropping it in the simulator and finding your voltage and currents. Good on that? Do we want to work through some others, or do you think that gets you started enough you can try those? I don't mind working with you.